Hi, everybody. Welcome to another session in Data Cloud. Today, we're going to be talking about simplicity. Simplicity by applying SQL. Is it possible to get more insights from your data at any scale? Is that possible with SQL? That's what we're going to see. Today with me, Leah and Rachel will be helping us to understand the power of SQL through a series of demos. We'll be seeing how to do machine learning, how to do advanced analytics around real-time processing. And we will be seeing as well how geospatial plays a role, as I said, at any scale. Data has been exploding in the last few years. So data has been generated like from different sources, lots of machines generating data, people generating data. But the main problem remains the value. 2/3 of the data is never analyzed, so no value can be actually extracted. A lot of data doesn't mean that we can extract a lot of value. The two main problems with that value is complicated to extract. One is because sometimes people don't have access to the resources required to process the data. This is something we solve at Google Cloud by leveraging a limitless data cloud. The second thing is around the skills. Do we have the right skills in the organization in order to extract that value? And one of the problems there, as we can see, is that many of the people extracting data or extracting value of the data are leveraging complex programming language like Scala, Java, Python, et cetera, et cetera. And this is basically not accessible to everybody. At the same time, we have a lot of people in the different organizations with SQL skills. And having those SQL skills mean that they can process data. But the question is, what can we do in order to extract more insights around that data? Is it possible to apply advanced techniques like machine learning or real-time processing by just using SQL? And another question is, can we do that at any scale? I think it is possible, and Google Cloud provides this. Let's have a look at the way we are going to do that. What we provide here is the way of doing advanced analytics, whether it's streaming analytics, machine learning, or geospatial at any scale. It doesn't mind whether your data is small, big, large, or petabyte scale. We have a solution based on the coupling storage and compute in a way that you're going to be able to use your SQL skills to do machine learning and real time just by leveraging SQL at any scale. Leah, all yours. You're going to show us now how this is happening in real life. Thank you.
Thanks, Miguel. Today for our demos, we'll be using the Transport for New South Wales open dataset. These are the ferries that transport passengers all over Sydney Harbour in Australia. This dataset includes real-time ferry locations, so GPS coordinates pinging in for each ferry every 10 to 20 seconds, and also detailed route, stop, and schedule information. Using SQL across Google Cloud, we'll be able to answer questions like, what is the average speed of each ferry in real time, and how long will it take to reach the next stop? Based on my current location, what's the most convenient stop? And also, what's the stop with the best on-time record? How will I know whether my ferry will be late? I will be able to predict whether or not it will be late to a stop. And of course, we'll be able to understand and share insights about ferry timeliness. Now, we only have a limited amount of time for the demo today, so I'll take you through how to use BigQuery ML and then hand over to my colleague Russell Nash to show you streaming analytics using SQL. BigQuery ML is honestly my favorite feature of BigQuery. Without needing to move your data out, you can train and deploy machine learning models directly using SQL. That means you've got data storage, analytics, and machine learning all right there within BigQuery. To start, all you need to do is write your feature engineering query in SQL. And once you're happy with it, you wrap it in 2 additional lines of SQL to create your model. And BigQuery trains and deploys it for you. And BigQuery ML also does a lot of feature pre-processing for you. For example, one-hot encoding. It can even do this for features that are inside of a nested array. It also does missing data imputation, standardization of numeric features, timestamp transformations. So for example, it can extract day of the month, day of the week, month of the year, hour of the day, in order to give you new features that give you better predictive ability. Once your model is trained, it's also deployed, and you can make predictions against it in SQL. Your models are subject to the same data governance and policies inside of BigQuery as the rest of your data. And you don't need to worry about provisioning infrastructure to host the model. It's all handled by BigQuery. So using the Sydney Ferry's live data set, let's go ahead and train a model using BigQuery ML to predict if my ferry will be late. And let's just jump over to the demo. Okay, so normally you would do a lot of exploratory analysis. Let's just assume that I've already done that. And this is the feature engineering query that I want to use as the basis of my ML model. So a few things to note. I've joined quite a few tables together, and that's no problem. In fact, I've even joined tables from different data sets together, which is fine for BigQuery ML. I've also created my labels. This is what I want to predict. It's whether or not the ferry is late. And in this case, I'm saying if the ferry is more than 2 minutes past the scheduled departure time, we're going to call that late. I've also created another feature where I extract whether it's a weekday or a weekend, because I think that'll give me better predictive value than just using the date. And I've cast this current stop sequence, which is a number in the existing data set. I've cast it as a string. And the reason that I've done that is that then BigQuery ML will treat it as a categorical variable and one-hot encode it for me. So once I'm happy with my feature engineering query, it's incredibly simple to train this model. So let me switch over to model creation. It's exactly the same query. I've just added these extra lines at the top, create or replace model, and all I need to tell it is what type of model is it? It's a logistic regression. And what is the label that I'm trying to predict? It's that is late column that I talked about before. We're short on time, so I'll show you one that I've trained earlier, but you can see it's very fast. So the training time was only 1 minute and 7 seconds, even though there are more than 180,000 observations in the data set that I used to train it. Once it's trained, I can jump over and look at the evaluation metrics and make sure that this is fit for purpose for my business case. Let's assume at this point that this is good. This is the experiment that I want to take forward. So the next thing I'm going to do is make it really easy for analysts to use using the transform clause. So transform allows you to specify all of the pre-processing that you do for model training and then have it be automatically applied when you make a prediction or you evaluate it. As you can see in this case, I've added the transform clause here, and I've moved all of that transformation that I spoke about before, casting stop sequence as a string, creating this other feature from trip date. This is now up into the transform clause. And it means that the analysts who use this, who want to make predictions, don't have to remember what I did with any of this transformation. This is actually best practice because this helps you avoid training serving skew. Okay, let's go ahead and make a prediction. It's extremely easy to do in SQL. It's just to select star from ml.predict, where I give it my model name, and then I tell it which data I want to pass in. And you can see, again, I haven't had to do any of those transformations. I haven't had to remember that current stop sequence is expected to be a string, or that this is actually a string rather than a trip date because it's weekend. That's all handled for me. All of that transformation is abstracted away from the end user. So let's run that and have a look at the predictions that we get. Great. So I can go in and see the probability against each of the labels, and that's great. Except that we really need explainability. So businesses are increasingly unhappy with a black box model where no one can explain why a prediction was reached. It's just not good enough in a lot of cases. Luckily, we have a tool to help you with that. So let's investigate how our model came up with these predictions using the ml.explainPredict keyword. Now, it looks extremely similar to what we've done before. In fact, there's only two differences. So number one difference is we're using ml.explainPredict rather than ml.predict. The other difference is we have to pass in a parameter telling the query how many of the top features we want to see attributions for. So in this case, I'm just going to see 4. And if we run this, then we can see now we have a column for top feature attributions. So if I open up this prediction, I can see that the top features were route direction, day of the week, route ID, and vehicle ID. But the really great thing here is that we're actually doing feature attributions at a prediction level, not a whole of model level. So it will actually vary from prediction to prediction. Let's open up this other one to contrast, and you can see the features are quite different. So this one has trip short name, departure time, vehicle ID, and route direction. All right, in summary, you can see that you have all the tools that you need to train high quality models in SQL, to make predictions against them in SQL, to explain the predictions in SQL, and there aren't any extra skills required. You don't have to worry about infrastructure, and you don't need to build a data pipeline to bring the data to your model. It's all stored together in BigQuery. All right, over to you, Russ.
Thanks, Leah. Hello, everyone. Now, Leah and I work on the same team, and we normally see eye to eye about most things technical, but I'm going to differ from her slightly when it comes to choice of our favorite BigQuery feature. As Leah said, she has picked BigQML as her favorite BigQuery feature, which I love, but for me, the best feature of BigQuery is its ability to have data streamed all the way into it. And one of the best ways to stream data in is using Dataflow. And one of the best ways to drive data flow is using SQL. And that's what we're going to spend the next few minutes talking about. So let's have a quick look at Dataflow itself. So Dataflow is a native service on Google Cloud that allows you to transform and analyze both batch data, but also streaming data as well. And as Miguel said, be able to do that at scale. Now, there's a number of ways that you can drive data flow. You can use Java, you can use Python, you can use a number of templates that we provide that allow you to do some common tasks, or most exciting for me, you can actually drive it using SQL. So going back to the demonstration scenario, we took the data set that we have of the ferries pinging their locations every few seconds, and we simulated that actually happening in real time. So we pushed that through into our cloud pub/sub messaging service, and then we're going to use Cloud Dataflow to actually answer this question, which is we want to calculate in real time the average speed of all the ferries on the water, but also we want to know how long is it going to take each of those ferries to reach its next stop. Now, for that second bit, we're going to need to do a couple of things. We're going to need to do a join between the streaming data and a stationary BigQuery table, because the information about the next stop, its lat long, etc., lives in a table within BigQuery. So we'll do that join, which we'll show you. And once we've got that information, then we want to use some of the geospatial functions within BigQuery to work out the distance between the ferry and the stop. And then because we know the speed, obviously then we can work out how long it's going to take to get there. So let's look across to the demonstration. And what you can see here is the Dataflow SQL editor that's specifically designed to help you write SQL against Dataflow. And on the left, you've got access to some of the resources that you might want to take a look at. So for us, we obviously want to look at the topic that we have that's got that data coming into it. And so when you pull that up, you can see that it looks very much like a normal table. So it's got fields, it's got data types. And as you'll see, when we write our SQL, we do exactly that. We treat it like a normal table. And so here's the SQL query, which I want to just point out a couple of things here. So the first thing you'll notice is that if you look halfway down, you'll see that from clause. The from clause looks exactly like it would in a normal SQL statement. Instead of a table, though, we're pulling from a pub/sub topic. And below that, you'll see that in a join statement, again, we're doing a join between streaming data and data at rest within BigQuery, but it looks just like a normal join. Where things get interesting, though, is where we need to introduce the concept of windowing into our SQL statement. And the reason for that is because we've got this data coming in that's unbounded. So if we want to create some metrics, we need to tell Dataflow over what time period to calculate those metrics. Now, there's a number of different windows we can choose. We could choose, for example, a tumbling window, which is a non-overlapping period of time. So we might say, calculate my metrics over this 30 seconds, then the next 30 seconds, then the next 30 seconds. Or for our purposes here, we're going to use a hopping window, sometimes referred to as a sliding window, where we may still choose the same period over which to calculate the metrics, so 30 seconds, but we want to do that every 3 seconds. And you'll see that in the hopping clauses there, where we've got an interval of 3 seconds, which is how often we actually publish those statistics, and the interval of 30 seconds, which is how long to actually include in that calculation. And so once we're happy with our SQL statement, we then would say create job. And from this particular dialog window, we can give it a name. We can choose an endpoint. So this will specify the region that this will run in and the destination. So we can choose BigQuery, or we could potentially choose Cloud Pub Sub as well for the output. So if we had downstream systems that wanted to get access in real time to our enriched data, we would push that into PubSub. For our purposes, though, we want to push it into a BigQuery table. So here we just give it a project, a data set, and then a table name. That table can exist, or it will be created if it doesn't already exist. And it's as simple as that. And then we would just hit create. And then we would then have a Dataflow job created for us. And the logic within that is based on our SQL query. Now, that's going to take a couple of minutes to spin up. So I've actually got one already running. And what I want to show you now is the SQL statement that we would use to actually do some of those geospatial calculations that I was talking about. So here's a statement which is pretty straightforward. The main bit of interest I want to show you is this line here, where we're actually doing a couple of geospatial type functions. So we've got the ability here, you can see, to create a geographic point from the lat longs. And then by using that stDistance function, we can then say, well, what is the actual distance between these 2 points? Very, very simple to use geospatial functionality in your SQL queries within BigQuery. There's loads and loads of really rich geospatial functions that you can use if you need to. So we've turned this SQL statement into a view. And then the last thing for us to do is to then simply show you this Looker dashboard that sits on top of the view. And so you can see on the left-hand side there, we've got the average speed, and then we've got the time periods, the vehicle ID, and then on the right, you can see the 2 derived columns that we've got there, distance, and then obviously minutes to next stop. So a very simple demo, but hopefully showed you the power of SQL on the Google Cloud Platform. So to finish out, just to recap what we saw today, Leah showed you using SQL to train a machine learning model. Then I showed you how to use SQL in real-time analytics, and we just had a sneak peek at some of the geospatial functions as well. If you'd love to learn more, on the left there you can see you can sign up for a BigQuery sandbox if you don't have access to one already. If you want to look at wider solutions, have a look at that link in the middle there. That'll take you to industry-specific solutions. And on the right there, that link will take you to some great stories based around the data cloud that we have. Thank you very much for joining us, and enjoy the rest of the summer.